Myself, Vinod Panara, and today we discuss some topic of property of steam of BME subject, that is Basic Mechanical Engineering. So, in this lecture, we discuss first types of steam. So, which are the type of steam? So, first one, wet steam. So, wet steam means it is a mixture of steam and water particle. So, when water particle and steam coexist in a form of mixture, it is called wet steam. Second one, dry steam. Dry steam does not contain any water particle. It is 100% steam at saturation temperature. So dry steam does not contain any water particle and temperature of dry steam is equal to saturation temperature. Then third one, superheated steam. So when dry steam is heated further at a given pressure, its temperature increase above saturation temperature, and this steam is called superheated steam. So there are mainly three type of steam: wet steam, which is a mixture of steam and water particle; dry steam, that is only steam at saturation temperature; and superheated steam. Now we discuss two definitions. First, dryness fraction of steam. So it is ratio of mass of dry steam present in the wet steam to the total mass of wet steam. So it is ratio of mass of steam in wet steam to the total mass of wet steam. So it is denoted by X, and X is equal to Ms divided by Ms plus Mw. What do you mean by Ms? Mass of steam in wet steam. And what do you mean by Mw? Mass of water in wet steam. Okay. And the value of dryness fraction for wet steam is always less than 1, and for dry steam it is equal to 1. Okay. Now wetness fraction of steam. So it is ratio of mass of water in wet steam to the total mass of wet steam. So it is denoted by X dash, and it is equal to Mw divided by Ms plus Mw. What do you mean by Ms? Mass of steam in wet steam. What do you mean by Mw? Mass of water particle in wet steam. And remember one thing, the summation of X and X dash is equal to 1 always. So summation of dryness fraction and wetness fraction of steam is equal to 1. Now we discuss enthalpy of steam. So first, what do you mean by enthalpy? It is summation of internal energy and flow work, as we have to discuss in our first chapter. So enthalpy, that is summation of internal energy and flow work. Now first one, enthalpy of liquid. It is denoted by HF, and the heat energy supply to the water to increase its temperature up to saturation temperature is called enthalpy of liquid. So when heat energy supplied to liquid or water, its temperature increase and up to saturation temperature, This heat energy is called enthalpy of liquid, and formula HF is equal to CPW TF minus 0. What do you mean by CPW? Specific heat of water, and it is equal to 4.186 kilojoule per kg Kelvin. What do you mean by TF? That is temperature of water. Okay, in degree Celsius. Then enthalpy of dry steam, it is denoted by Hg. Definition: the amount of heat energy supply to convert 1 kg of water into 1 kg of dry steam from its freezing point, and that is equal to Hg, enthalpy of dry steam. What do you mean by dry steam? It is only steam, does not contain any water particle, and its temperature is equal to saturation temperature. So Hg is equal to Hf plus Hfg. That is formula of Hg, and this all value Hf, Hfg, Hg, all value that we have to taken from steam table in example. Now third one, enthalpy of wet steam. It is denoted by small h. What do you mean by wet steam? It is a mixture of steam and water particle. So the total amount of heat energy supply at constant pressure to convert 1 kg of water at 0 degree Celsius into 1 kg of wet steam at particular dryness fraction. So dryness fraction, it is denoted by X, that we have already discussed. So H is equal to Hf plus X Hfg. Then enthalpy of superheated steam, it is denoted by H superheated, the total amount of heat supply to convert 1 kg of water at 0 degree Celsius to 1 kg of superheated steam, and H superheated is equal to Hg plus Cps T superheated minus T saturated. What do you mean by CPS? Specific heat of superheated steam, and T superheated, temperature of superheated steam, T saturated, saturation temperature. So this is about enthalpy of steam. In this topic, we have to discuss 4 subtopics. First, enthalpy of liquid, enthalpy of dry steam, enthalpy of wet steam, and enthalpy of superheated steam. Now next one, specific volume of steam. Now what is difference between volume and specific volume? So when mass of steam, that is 1 kg, we have to use this word specific volume. So first one, specific volume of saturated water, it is denoted by Vf. The volume occupied by 1 kg of water at the saturation temperature at a given pressure. That is specific volume of saturated water. Now second one, specific volume of dry steam. It is denoted by Vg. So the volume occupied by 1 kg of dry steam at a given pressure. Now third one, specific volume of wet steam. It is denoted by V. The volume occupied by 1 kg of wet saturated steam at a particular given pressure, that is specific volume of wet steam. It is denoted by small v, and it is equal to X into Vg. What do you mean by X? Dryness fraction. And what do you mean by Vg? Specific volume of dry steam. Now specific volume of superheated steam. It is denoted by V superheated. So the volume occupied by 1 kg of superheated steam at the superheated temperature at a given pressure. So it is V superheated, and V superheated is equal to Vg into T superheated divided by T saturated. What do you mean by Vg? Specific volume of dry steam. V superheated, specific volume of superheated steam. Now we discuss internal energy of steam. So internal energy, that is difference between enthalpy of steam and external work of evaporation. So it is difference. So internal energy of dry steam, it is Ug. It is equal to enthalpy of dry steam minus external work of evaporation. So Hg minus P into Vg. Second, internal energy of wet steam, U is equal to Hg minus Xp into Vg. What do you mean by X? Dryness fraction of wet steam. Then internal energy of superheated steam, it is U superheated is equal to H superheated minus P into V superheated. So this is about internal energy of steam. It is difference between enthalpy and external work of evaporation. And we discuss three type of internal energy. So in this lecture, we discuss enthalpy of steam, specific volume of steam, internal energy of steam, and some definition. And also we discuss types of steam: wet steam, dry steam, superheated steam. Okay, thank you.